Hi, 5th grade. It's Mrs. Skioka with your flipped math lesson for today, 8-1. Today's objective is I can write numerical expressions using variables like letters. And these are called algebraic expressions. So let's talk about a few words here in our objective. So the first word, numerical expression, that just means an equation or a number sentence. Variables are letters that we use like A, B, C within an equation, and that just stands for a number. And then when we put those together, then we have an algebraic expression. We'll talk a little bit more about that. So how can you write an algebraic expression? That is our big question for today. How are we going to be able to write these algebraic expressions, which is what algebra is? Well, here's an example. Drew bought CDs for $10 each. How can you represent the total cost of the CDs? So we know that the CDs cost $10 each, and we're trying to represent the total cost of the CDs. So we don't know how many he bought, we just know that he bought them for $10 each. And if we went through, we made a chart, then we would know. We'll do that in just a second. So a variable is, we just talked about that, those are those letters that we use. It's a quantity that can change or vary, and it's often represented by a letter. Okay, some of the letters we've used in the past are X, Z, Q, D. You can use any letter, it doesn't really matter. When you were younger, your teacher probably used just a question mark, or sometimes they might leave like a blank, and then that means that you didn't know what the quantity was. Well, that's the same thing, except this time we're using letters. Okay? So let's say we did make a chart to show how many CDs Drew bought. If he bought one, then the total cost would be $10 times 1. If he bought two, the total cost would be $10 times 2, and then so on and so forth. So we know that the operation is multiplication. We're multiplying it times 10, or $10. Now if we write down what that equation would look like, or the expression, then we would write it first like this. $10 times n. So n represents the amount of CDs that he bought. And we don't know how many he bought, but if we did, then that number would be n. Okay? Now, I've got the dollar sign here. I could also write it like this. 10 times n. Okay? So on this, all I did was take off the dollar sign. Now, when we have these letters and we multiply them, if we put it next to the letter, the number next to the letter, without the multiplication symbol, it still means multiplying, okay? So if I have 10n, that means 10 times n. If I had 7n, that means 7 times n, okay? If I had 12n, that means 12 times n. Okay, anytime we have a number next to a letter, that means that we are multiplying the letter times the number. Okay? Okay, so an algebraic expression is a mathematical phrase that has at least one variable and one operation. And remember, a variable just means a letter. So it might be X, it might be Y, it might be Q, it might be D. It could be any letter of the alphabet, and one operation, meaning it has either adding, subtracting, multiplying, or dividing. Okay, so it has to have both of these things. It has to have a letter, and it has to have an operation. So here is our operation from before, 10 times n, or 10n, which is the same thing as 10 times n. Remember, if you have a number next to a letter, you're just multiplying those together. The operation is multiplication. The variable is the n. Okay? So here's some examples of algebraic expressions. Remember, it has to have a variable and has to have an operation to be an algebraic expression. So if I had this expression, it said $3 more than the cost of C. $3 more than the cost of C tells me that the operation is addition. The cost C is the variable. And the algebraic expression that I could make from this statement is $3 more than the cost of C, so C plus 3. Now with addition, we know that we could also do 3 plus c, and we'll get the same answer. Okay. Now what doesn't work with every operation, but we know it does with addition and with multiplication. Here's another one. 12 pencils decreased by a number n. So decreased tells me we're subtracting. So our operation is subtraction. Our variable is the letter n. And our algebraic expression will follow the sentence. 12 pencils decreased by a number n. So 12 minus n. Our next one says 5 times a distance d. 5 times a distance. So times lets me know that we are using the operation multiplication. The variable is the letter d. And the algebraic expression would be 5 times a distance d. Another way I could write that is just 5d. Okay, and that only works with multiplication. You can't do this with any other operation, just multiplication. A apples divided by 4. So A apples divided by 4. Well, this tells me explicitly that we are using division. The variable is A, and then the algebraic expression, A apples divided by 4. Or I could put A apples divided by 4, or I could even put it like a fraction, A apples divided by 4. All of these equal the same thing, okay? They're all equal, equivalent fraction, or equivalent expressions. They mean the same thing. Here's another one. 5 less than 3 times an amount of p. Okay, so this one has, sorry, that kind of cracked me up. This one actually has 2 operations in it. 5 less than 3 times an amount p. So I know the operation is going to be subtraction and multiplication. Less than means subtraction, times means multiplication. My variable is the letter p. And then I have to do my algebraic expression. So I'm going to have to really think about this sentence. 5 less than 3 times an amount p. And this one, is you're going to actually write it a little bit backwards, because 5 less than is going to mean 5 less than 5, or 5 less. So I'm subtracting 5. Now I can't put that at the beginning of a sentence. That would look really strange, right? You don't put minus 5 and then put plus 2 or something like that. You would put like 2 minus 5, which would be hard to do. But we put our minus 5 towards the end, okay? 3 times an amount p. So 3 times an amount p minus 5. Now I can put the 3p together minus 5. And that makes it even easier for me to see and figure out what is going to happen in what order. Next time we're going to be talking about when we have operations that have two different operations in them, which one we have to do first. All right, let's see. Let's practice a few and let's see how you do. So we're going to write an algebraic expression for each situation. So remember, algebraic expression means that we're using a variable like a letter, and we're going to use an operation like multiplication or subtraction, addition, division, so on. So number 1, the difference of a number t in 22. The difference of a number t in 22. Well, I look at that, I see difference. I know I'm going to be using subtraction. A number t. So t is my variable in 22. Now t came first in my sentence, t in 22. So I know that it's t minus 22, not 22 minus t. Because if it said the difference of 22 and a number t, then I could use this one. But it doesn't say that. It says a number t and 22. And find the difference of that. So I know I've put it in the right order. Number 2. M bicycles added to 18 bicycles. Okay, can you add that, can you do that expression really fast? Okay, so I know we're adding It even says it in the sentence. So I'm using addition. M bicycles to 18 bicycles. So M plus 18. Okay, easy enough. Number 3, 11 times a number Z. Okay, so 11 times a number Z. Okay, so we can do 11 times Z, or just write 11Z. Now what you're going to find is most of the time it's going to be written like this, okay? Because oftentimes in our algebraic expressions we use the letter X. So if you use multiplication and the letter X and you have X times 5, it's hard to see that that's X times 5. It looks like XX5, okay? So usually you're going to see this. So start getting used to multiplying, when we multiply, having those letters next to the numbers, and just know that this means multiplication. Number 4, 4 less than 5 times a number G. This one's trickier. 4 less than 5 times the number G. So I know I'm going to do less than, which means subtraction, 5 times a number, which means multiplication. And I'm taking 4 less than, so I'm going to be doing minus 4, 5 times the number G. So 5 times the number G minus 4, or even better, 5G minus 4. All right, number 5. What's the variable in the operation in 8y? Let's see if you can remember. What's the variable in the operation in 8y? If you said the variable is the letter y, you're correct. If you said the operation is multiplication, you are correct. Good job. How about this one? N more students than the 8 students sitting in each of the 3 rows. This one's a little tricky. N more students than the 8 students sitting in each of 3 rows. This is another one where they're trying to, they're telling you what goes at the end at the beginning of the sentence. So N more, so I know I'm going to be adding to show more than the 8 students sitting in each of the 3 rows. So I know that there are 3 rows and there are 8 students in each row. Sorry, I'm not necessarily drawing 8, but I know that that is multiplication, right? Because that looks like an array. So I'm doing multiplication right there. So I know I've got 8 times 3, and it says n more. So n plus n. Okay, so this part has to come together first, so I'm going to put parentheses around it. Because the 8 students sitting in each of 3 rows has to be together. Okay, it didn't say 8 times 3 plus n. So if I don't have these parentheses around it, then I don't know what happened first. But the parentheses are going to tell me what's happening first in the problem. Okay, I could also just go ahead and write 24, because 8 times 3 is 24, and 24 plus n would be where I'm working towards I'm solving the problem, or I am breaking it down a little bit further. Okay, so now it's your turn. Let's see how you do. Write some algebraic expressions. Number 7. A number p increased by 22. Pause the video and then I'll show you what the solution is. Alright, so if you said p plus 22, you got it correct. Good job. Number 8. 15 divided by a number r. Okay, if you said 15 divided by r, you got it right. If you wrote it this way, 15 divided by r, that could be correct too. If you said 15 over r, like a fraction, that is correct too. Okay, they all mean the same thing. Good job. Number 9. 12 more points than a number d times 8. Okay, so this one they're giving you information here at the beginning of the sentence. It's going to go at the end of the equation. 12 more points. So I'm going to be adding 12 on to the rest of it. Then a number D times 8. D times 8. Okay? Or I could put 8D, or I could put 8 times D right there. Okay, they're interchangeable with multiplication, just like addition. We use that commutative property. So 8D plus 12, or I could put it in parentheses like this and put 8 times D plus 12, or D times 8 plus 12. They're all the same thing. Number 10, 6 less than 7 times a number B. Okay, so again, they are giving you some information here at the beginning that you're going to put on the end of your equation. 6 less than, I know less than means subtraction. I'm going to take away 6 from the rest of the sentence. 7 times a number B. 7 times the number B minus 6 is what the sentence is telling me to do. 6 less than, there's my 6 less than, 7 times the number B. Okay, now so I know that this goes together, I could put parentheses around it. I could also just go ahead and put the letters together without the multiplication symbol, and 7b minus 6. Okay, number 11, 5 more than the product of x and 9. Okay, so again, they're telling you more than, which means addition, and that information needs to go at the end because you also have this section right here. So you're adding 5 to whatever you're doing here. So 5 more than the product. Product means multiplication of x and 9. So x times 9, see what I was saying there about having two x's is very confusing, plus 5. So to make that less confusing, we'll put 9x plus 5. And just as a note, whenever we do this where we put the number and the letter, we always put the number first and then the letter. We wouldn't put x times x9, and we wouldn't put z5 or y3. Those are incorrect, okay? You would always put the number first and then the letter. Okay, so you could have 3y, you could have 5z, you could have 9x, but you wouldn't do it the opposite way. Always, 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 the number comes first, and always, 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 the letter comes second when you are multiplying the number and the letter together. The reason for this is, I can show you one reason anyways, is if I have y3, what that really looks like is y to the third power. Okay, and we don't want to get that confused with 3y because that doesn't necessarily mean the same thing, right? Remember, when we do powers, we are multiplying the number times itself, so that would be like y times y times y. This is y times 3, and that's different. All right, number 12. 7 times the difference of y and 4. All right, so I've got 7 times, and I'm going to be using multiplication. The difference means subtraction of y and 4. So first I've got the difference of y and 4. Difference means subtraction. And I'm going to take that and I'm going to be multiplying it times 7 because it said 7 times. So I'm going to be multiplying that times 7. So I'm going to have y minus 4 and put that in parentheses so I know that section goes together times 7. Okay? All right, that's it. We are finished. All right, if that felt comfortable for you, then I'm sure you're going to do great on the assignment tomorrow. All right, I'll talk to you later. Bye-bye.